Embarking on a new chapter, it's all about electricity. We will start with electrostatics, meaning first we will study how charges are created, not so much created, but how objects become charged, because charges have been created well before we even knew about them. If you remember chemistry, you know that any atom consists of nucleus, where we have protons and neutrons, and electrons are on the outside, sort of like a shell or a cloud. So what we're going to talk about today is how objects that are neutral in the beginning all of a sudden become charged. Overall, there are two types of charging, and we're going to talk about the charging by contact. That is something that you encounter in everyday life, especially in the winter. You wear lots of layers, and then sometimes you get zapped when you touch your car, or maybe open the refrigerator in the grocery store, and that's called static electricity. You've all heard that expression. So in this picture right here on the screen, you see that we have a rod that is made of ebonite. What happens is that electrons from the fur get transferred onto the rod. And notice how we have 1, 2, 3, 4, 5, 6 pluses. Doesn't mean that our fur has 6 protons. No, what they're trying to show us is that 6 electrons are now missing. That's why the charge is positive. And then where did they go? 1, 2, 3, 4, 5, 6. These 6 electrons are now sitting on the ebonite rod. So we have charging by contact in this case. And in your worksheet, you can see that every object can be charged by this method. It can be a conductor, it can be an insulator. Another example is the opposite, is when we have the cloth again. We had the cloth and the rod. If the cloth is made of silk and the rod is made of glass, then notice how now cloth has extra minuses. That means that electrons, and this one misses 5 electrons, went boom onto the cloth. What you should see that every time it's 6 by 6. So 6 electrons went from one object to another. Total charge, Q is used for charge, is conserved. We cannot just destroy electron all of a sudden. It can go somewhere, but then it still will exist. So the same thing here. We had 5 electrons, went from one object to another, and that means that this one is now missing 5 electrons, and this has extra. It gained 5 electrons. We don't measure charge in electrons. If you ever heard of amps, that's how current is measured. And we don't count how many electrons went through a wire in a second to figure out amperage. What we do count is the amount of charge. And charge is measured in coulombs. Here's the picture of Charles Coulomb. He studied the interactions between charged objects. Charges can attract and repel each other. You know that opposites attract. So plus and minus would be attracting each other. 2 negative charges would be repelling each other, and 2 positive charges would be repelling each other. Why do we measure charge in coulombs all of a sudden? It's to commemorate the impact that this particular scientist made in the study of electricity. So C, big C, will stand for a coulomb. Now, 1 coulomb, it's huge. As a matter of fact, if you have 1 amp, which is 1 coulomb, going through your heart in 1 second, it will stop your heart. Mind you, I'm not saying it will kill you, but it will stop your heart. The charge of 1 baby electron, so this little e is not the power, is not the exponent, and it's not the Euler's E. This is the symbol for 1 electron. So the little e in physics will stand for 1 electron. And notice how tiny the charge of 1 electron is. It's 10 to the negative 19th. Negative 1.6, 10 to the negative 19th coulombs is the charge of an electron. Well, then what is the charge of a proton? Why are atoms neutral? Because a neutral atom has the same number of protons and electrons. The number of neutrons can differ, and we can end up with isotopes. The charge itself, the charge of an electron and the charge of a proton, are equal and opposite. So plus and minus. You do not have to memorize it. You just need to know how to manipulate. How many electrons does an object gain or lose? How do we know it? Or, on the other hand, if we know how many electrons an object lost or gained, how are we going to figure out what the charge is? So here's the formula. N equals Q over E. Remember how I can rearrange this. What if I want to find the Q? What is the charge of an object if I know how many electrons are lost or gained? That's how we would recalculate it. So 2 questions. How to figure out the charge. If you know the number of electrons gained or lost, this is the formula you're going to use. You're going to multiply the number of electrons that were gained or lost by the charge of an electron, which is negative 1.6 10 to the negative 19. And then if you wanted to know how many electrons were lost or gained, you're looking for the number, so you won't have any units there. You're just going to have a number, and you will take the charge and divide by the electron's charge. So let's work on some examples. What is the charge of an object that has gained 1,000,000 electrons? You need to know if it gains, then you have extra electrons and the charge will be negative. If it loses, then the charge on the object will be positive. So we have gained 1,000,000 electrons. So I'm going to take 1.6 times 10 to the negative 19, and I will multiply it by 10 to the 6th, because 1,000,000 has 6 zeros. So I can rewrite this as 10 to the 6th. Remember how you deal with powers. When you multiply, you add the exponents. So negative 19 and 6, when I add them together, I end up with 1.6 times 10 to the negative 13 coulomb. And because, again, I'm looking at it gained, so then I'm going to say that the charge on my object is negative. Gaining electrons creates a negative charge. Example 2, how many electrons did an object gain or lose? So first, did it gain or lose? If I have a positive, in other words, they didn't put a minus. If they didn't put a minus in front of our charge, that means that it's positive. And if it's positive, that means that our object lost electrons, so we are going to use lose. So their electrons are lost. How many? Remember, little mu is 10 to the negative 6th, so my charge is 3 times 10 to the negative 6 coulombs. How am I going to figure out the number of electrons? Remember, to get the number of electrons, I'm going to take the charge and divide by the charge of one electron. So another method that you can use is you take 3 and 1.6 and put it into your calculator, and then look at, if I have 10 to the negative 6th divided by 10 to the negative 19th, that means that I do 10 to the negative 6 times 10 to the positive 19. That is because I'm subtracting. When I'm dividing exponents, I'm subtracting them. It's like 6 minus negative 19. So that will be 6 to the 13th. So take 3 divided by 1.6, and that will be 10 to the 13th. And that's just the number. That's how many electrons were lost. I'm going to look at some of the examples that are in your worksheet. So gained, lost, lost, and gained. And we need to figure out the charge. They tell us that the object gained electrons. That tells me that the charge is going to be negative. I'm going to have extra negatives. The object lost electrons, that's going to be a positive charge. It is missing some negatives, so it's overall positive. Lost, again, overall positive, missing some negatives, and then gained, negative, because we have extra negatives. Now, how many? 8, 10 to the 12th. 3, 10 to the 10th. 7, 10 to the 15th. 1.2, 10 to the 13th. Lots and lots of electrons. See how huge those numbers are? But the charge overall is going to be tiny. That is because one electron has 1.6 10 to the negative 19 coulombs. Then when you consolidate these two numbers, 8 times 1.6 is 12.8. 3 times 1.6, 4.8. 7 times 1.6 is 11.2, and then 1.2 times 1.6, that's 1.92. And now I'm going to deal with my exponents. When I have multiplication, we just add our exponents. So that's going to be 10 to the negative 7th, 10 to the negative 9th, 10 to the negative 4th, and 10 to the negative 6th. Coulombs, 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 and coulombs. For honors, it's mandatory to have this in proper scientific notation. 1.28, see how I moved my power of 10 to the left? Then I'm going to put my exponent to the right, so it's only times 10 to the negative 6th coulombs. That's just the rule. If I move my point to the left, I'll move my power to the right. 4.8 is already as is. I don't need to do anything. Here I'm going to do 1.12 10 to the negative third, or I can say 1.12 millicoulomb, and then 1.92 10 to the negative sixth is already as is, so I don't have to do anything about that. The next one, I need to figure out how many electrons were gained or lost. If you're wondering, I'm using the CP version. So electrons gained or lost include the number and the word. So I'm going to say how many, and then I'm going to add whether it's gained or lost. Well, let's start with the back. If I have a positive, then this means lost. If I have a negative charge, that means that the object gained extra electrons. Then again, gained because it's negative, and lost because it's positive. Missing electrons makes overall positive charge. Having extra electrons makes overall negative charge. How big is the charge is given to us. We're now trying to figure out how many electrons that is. Number of electrons equals, and I take the charge that is given to me and divide by the charge of one electron. So 8 10 to the negative ninth over 6 10 to the negative 19. Again, if you're using a calculator, make sure that you put parentheses around this. Otherwise, your answer is going to be incorrect. Or if you're proficient with powers, with exponents, you can say it's 1.3, and then you do times 10. 19 goes upstairs with a plus, so that becomes just 10th. And there's no unit, that's just the number of electrons, 1.3 10 to the 10th. Electrons were lost. That's how we ended up with a positive charge. Then I take 9.6 times 10 to the negative sixth, and I divide that by 1.6 times 10 to the negative 19. 9.6 over 1.6 is 6, so I'm going to say 6. And then this goes upstairs with a plus, so that's going to be 10 to the 13th is your answer. Do the same for the next ones, and honors, you have a few more. So that's how you figure out the charge when it was gained or lost. And the next video will be a little more complicated on if you have two objects with different charges and they're conductors, meaning that they can share through a wire, they can share their electrons. What will happen? I'll see you in the next video.